alcohols, phenols and ethers. See, these are very important class of organic compounds which mainly consist of what? An alcoholic group or OH group or a functional group which is having an what? An oxygen. The general formula of all these compounds is CnH2n plus 2 oxygen. So what we can find out from this formula is that these are the organic compounds in which the ratio of the carbon and hydrogen will be always of an alkane, and along with this they will be having one extra oxygen. Now, in a very simple language, we can write alcohols as what? The organic compounds which are having OH group, which is there actually after substitute when the hydrogen is being substituted by this group. So these are called alcohols. So when the OH group is attached to any aliphatic chain, it's called alcohol. When the same OH group is attached to a benzene ring, we call it phenol. And remember what the most important thing, that ethers are functional isomers of alcohols. Yes, so their general formula is also CnH2n plus 2n oxygen. The only difference is that the ethers are isostructural to water molecules. Water molecule, H2S, like this. So they have a bent shape in which what we have is, actually ethers are ROR group. So oxygen is the one which is the connecting atom, which is connecting what? Two alkyl carbon chains. Now, these carbon chains, this oxygen and this is sp3 hybridized. This is sp3 hybridized. So that is why due to this lone pair, lone pair, lone pair, bond pair repulsion, this becomes bent shape. So these are ethers, ROR group, functional isomers of alcohols. And when the same OH group is present on benzene, we call them phenol. Now let us do the classification of alcohols, phenols and ethers. Let us take first classification of alcohols and phenol. First classification is on the basis of number. And on the basis of number, they are of three types. We call them monohydric, dihydric, and polyhydric. Monohydric contains one, dihydric contains two, polyhydric contains three or more. Now let me give an example. If we have like methanol, it is what is monohydric. If we have this compound which is called glycol, this is called dihydric. And if suppose we have what? A glycerol, we will call it polyhydric. Similarly, we can have what? When benzene ring is having only one OH group, we call it phenol, yet it is monohydric. If we have two OH groups like this, it is dihydric. And if we have three OH groups, yes, we call it polyhydric. So this is how we classify the alcohols on the basis of their number. The second classification is on the basis of type of carbon atom. The first in the category is, on this basis they are of two types. The first in the category is your sp3 carbon atom. So when the carbon atom which is having an OH group is sp3 hybridized. Now on this basis they can be of three types. They can be primary, they can be secondary, or they can be tertiary. Let me explain it to you. if the carbon, the OH group is attached to what the primary carbon, we call it primary alcohol. If it is 1 degree, if it is attached to a secondary carbon 2 degree, we call it secondary alcohol. See, all these are carbons which are having OH or sp3 hybridized. And similarly, we can have an OH group bonded to what? A 3 degree, which is also called tertiary alcohol. So this is how we classify them on the basis of the degree, and remember that all the carbons in this are sp3 hybridized, so we have primary, secondary and tertiary. Then the second one comes as the sp2 hybridized carbon atoms. The second one are sp2 hybridized carbon atom. Now sp2 hybridized carbon atom, in this we can have majorly two, allylic and benzylic. See, again, it is not sp2, but it will be, yes, part of sp2 hybridized carbon system. Like this is allylic alcohol, and this is benzylic alcohol. These are not directly bonded to an sp2 hybridized carbon atom, so we can write this as the ones which are part of sp2 carbon atom system. So they can be allylic or benzylic. You can see that this carbon, though is sp3 hybridized, but it is a part of what? An sp2 hybridized carbon system chain, that is why they are called allylic. And this again is this carbon is sp3 hybridized, but this is a part of an sp2 hybridized system, so they can be benzylic. Now these allylic or benzylic can also be primary, secondary or tertiary also. Like, and I can give you an example. Like there can be, if it is like this, let me put it like this for you. Now this is a secondary alcohol which is part of what? Allylic, and this is a tertiary alcohol which is again is a part of what? Allylic group. Whereas similarly, we can also have a benzylic one, benzylic alcohol which is secondary. We can also have a benzylic alcohol tertiary. Now the next category is OH group bonded to sp2 carbon atom directly. So they can be either vinylic or it can be phenolic, CH2 double bond CHOH, or it can be like this. What we need to know is, in this, the OH group, yes, is bonded to what? sp2 hybridized carbon atom, but yes, this will, the allylic one, vinylic ones will not be stable because they will show tautomerism and they gets changed to their corresponding aldehyde or a ketone, whereas yes, the phenol, we know that's in an enolic form and is much more stable than its tautomeric form. That is why it always exists in this phenolic form. Now let us see the classification of ethers. See, ethers are of two types. One we call them as simple or symmetrical other are called mixed or unsymmetrical. See, when we call them simple is when the two R groups attached to the oxygen are this, we actually denote both the R's as R and R dash. So if the R is equal to the R dash, that means both the alkyl groups are similar. We call them simple or symmetrical ethers. Like we have CH3O CH3 dimethyl ether, or we have what? The diethyl ether. So you can see that here both the sides are having what? Same number of carbon atom chains. And when we put it like this, that this is the ether, and the R is not equal to R dash, that means both the alkyl chains are not equal, they are not similar, we call them what? Mixed or unsymmetrical ether. So it can be like this, put up in a very simple way. So one side is having one carbon chain, other is having a two carbon chain. So this is how we classify them as simple or mixed or symmetrical or unsymmetrical.